Hi, today I received an email from DigitalOcean. Uh, from DigitalOcean, informed me that they have rolled out mitigation to um, resolve the Intel machine check error security vulnerability. And I have a droplet running in the DigitalOcean as a personal VPN services. And so this the just let me know that my droplet are secure. And so I want to talk a little bit about this security vulnerability. So here's an article from Intel website, a technical deep dive about this machine check error avoidance on page size change. So this is the actual CVE number, and so here is the description of the vulnerability. So it's good to read to understand this security problem. So basically, it's just like each process in Linux have a virtual memory address mapped to physical address using page tables. So the page table page usually has a standard of 4K page size. And there is also huge page size, which is like 2 megabytes, 4 megabytes, and 1 gigabyte page size. So the vulnerability is like if some malicious user running a malicious virtual guest, and if it's load a malicious kernel module to change the page size before the cache is invalidated in the TLB. So the TLB is a translation look-aside buffer, a CPU memory cache to the from the virtual memory address to the physical memory address. And so if the malicious user load a kernel module and change the page size from say 4K to a huge page size, and it will cause machine check error and to crash the hypervisor, say the KVM hypervisor in the Linux kernel. So yeah, so here is a more technical article, deep dive you can read it through. So and in Red Hat, so Red Hat also affected by this, and here is Red Hat. Red Hat actually has a diagnose bash script, which I downloaded. So the bash script is just to check the if the Red Hat distribution is affected by this security problem. And I downloaded it, but I want to check the Ubuntu, if my Ubuntu, my home Ubuntu machine is affected by this Intel machine check problem. So this is a script, and if you open this script, it will show all the vulnerable CPU models. And if you have a say physical server running Linux with this CPU model, and if you also happen to have a KVM hypervisor running for your virtual machine, so it's worth running this script to see if your CPU hypervisor is affected by this. So I'm running Ubuntu on my physical machine, And so if I run this script, it says vulnerable. So this is CPU model is vulnerable. My CPU model is 60, and the hex is 0x3c. So if we double check the script, and the CPU model 3c here is in the list of affected CPU model. So, and you can modify this script and so basically just comment out all the exit one in the bash script, because the exit one say it's just check if it's a Red Hat distribution, but you can just comment out the exit and it will just should run on your Ubuntu or other distribution. And there are other say, so this is check if your OS has a Red Hat kernel, but you can just comment out the exit one, right? Yeah. So I'm wondering what's the actual mitigation in the kernel. So I looked up from the Linux kernel mailing list, and so if I search this CVE number, I happen to see that this is the kernel patches merged in the upstream. So that's the actual kernel patch. And so here is a documentation added in the kernel to talk about the mitigation method. Add the initial, so the ITLB, the I means for instruction, so TLB look aside the translation buffer is like the cache for the executable code instruction cache. And here is the mitigation. So here is talk about the mitigation, KVM hypervisor mitigation. And so when you boot up your Linux kernel on the hypervisor, you can give this kvm.nx huge pages. So nx I think is meaning not executable huge pages, and you can give it to a force or off, which is disable the mitigation, or auto. So maybe you want to use a force or auto for the mitigation. So yeah, so that's I think it's a useful to understand this security a little bit more from the technical side. And yeah, thank you.